What is up, mathematicians? We are now on to section 1.3, and this one's all about trig functions. I know probably a lot of you right now are like, frick, I don't know the unit circle, like I don't remember that. Well, it's gonna hit you in the butt for not knowing it, but you just gotta learn it. And I have a trick for you guys, so don't worry about that. But first, what's a trig function? There are 6 basic trig functions. So, basic trig functions. So first, let's say that we have this little graph, really useful to use. And I have my unit circle. It's a unit circle because its radius is 1. So if I choose this point right here, I can draw a triangle from here down and over to here. And this point right here, it's gonna have the coordinates x, y. I can also enlarge this triangle so that this is x, this is y, this is r, and we're also going to have the angle right here. We like to call this angle theta. All right, so trig functions are ratios of these 3 what are they called? Sides of the triangle, excuse me. So we have sine, and we write sine of theta, right? Remember, it's a function, so of theta. If you guys remember SOHCAHTOA, it's going to be opposite over of the angle over hypotenuse. So it's going to be y divided by r. Cosine, we write cos of theta. That's going to equal adjacent over hypotenuse, or x over r. Tangent, it's going to be tan theta. And that's opposite over adjacent. And the TOA part of SOHCAHTOA, so that's going to be y divided by x. Those are your basic 3, and then they kind of have some siblings that come along with them. So we have cosecant. We write that as CSC, cosecant of theta, and that one's going to equal r divided by y. We just have plain old secant. Write him as SEC of theta, and he's going to equal r divided by x. And then there's cotangent, COT theta, and that one's going to equal x divided by y. So those are our 6 basic trig functions. We're actually able to represent each one of these bottom 4 in forms of sine and cosine. So we can rewrite, I want to write this is not in the form. Let's do as a function of sine of theta and cosine of theta. So a very popular one is that tangent. Where did that circle come from? Why couldn't you make a pretty circle earlier? Oh my gosh. I got rid of my theta. Okay. So tangent of theta is sine theta divided by cosine theta. And we can see that here, if I divide sine by cosine, I get y divided by x because those r's cancel out, and that's exactly what tangent is. If I go look at cosecant, r divided by y, well, sine is y divided by r, so that means that cosecant theta is just the reciprocal, or 1 over sine theta. Similarly, secant of theta is going to be 1 divided by cosine of theta. And cotangent of theta, I hope you guessed it, it's 1 over tangent of theta. Well, tangent's just sine over cosine, so I can also write cotangent as cosine of theta divided by sine theta. Pretty cool, right? So, before we move on, I kind of wanted to show you guys a way that I remember the quadrants of the unit circle. So, let's review. Yeah, that's what I want. So, we're pretty familiar with the unit circle in the first quadrant. The first quadrant is this guy right here, quadrant 1. Quadrant 2 is right here. Quadrant 3, leaving this guy right here to be quadrant 4. Now the way that I learned it is that they're all positive. So sine, cosine, and tangent are positive in the first one. Sine is positive here. Cosine's positive here. And tangent's positive in the fourth quadrant. And you know you did that one correct because all students, oh no, I messed it up. Okay, ignore. I can't start this lecture over. I wasn't correct. What color did I make tangent? Purple. See, we all make mistakes. As embarrassing as they are. Okay. There we go. So the phrase that I use to know if these are right, I was about to tell you the phrase and then I realized it was wrong, is because all students take calculus. And it goes in that order. And you see that I just made a C right here. That means I'm correct. I didn't make a C earlier. I made like a S, which means I'm stupid. So that's how I know that quadrant 1 sine of theta, cosine theta, and tangent theta are positive. In quadrant 2, it's just sine. Quadrant 3, it's just tangent of theta. I like to put these in parentheses just because it helps really hone in that it is a function. And then quadrant 4, it's cosine theta. I like to use this trick so that I only really need to know my unit circle for this quadrant, and then I can apply that sine is positive here, tangent here, and cosine here. So that's a nice trick. Another useful thing about trig is that there's identities. So the most common one is that sine squared of theta plus cosine squared theta equals 1. Let's label this section. Whoa, how do I do this? So cosine, we'll write it how I wrote it before. sine squared theta plus cosine squared theta equals 1. We write the squared right here, just so you know that it's like the function squared, not theta squared. So it's basically saying cosine times cosine, not cosine of theta squared. All right. So with this identity, I can get 2 more using these guys, these functions of sine and cosine. So if I take each one of these and divide it by a sine squared theta, which I can do because when I'm doing to one side, I'm doing it both sides. So that tells us sine squared theta divided by sine squared theta, or anything divided by itself, that's just 1. And then cosine squared over sine squared, we can write that as cosine theta divided by sine theta squared plus 1 divided by sine theta squared as well. And I forgot a squared. Why did no one tell me? So scroll back up here. Well, I know cotangent is cosine divided by theta, and 1 over sine is cosecant. So then I get that 1 plus cotangent squared of theta equals cosecant theta. These are really useful squared identities. I only ever learned this first one right here because I kind of learned the quick hand to remember the other 2. So then if I take this original one up here, so I'm going to star this because he's important. Star this, you're also very important. So if I take my top function and I divide it by cosine, so I have sine theta, sine squared theta, plus cosine squared theta equal to 1, and I now divide that by, what did I call cosine? Orange. Cosine squared theta then we're going to get sine divided by cosine. That whole quantity squared is going to give me tangent squared theta plus anything over itself is 1. So cosine squared divided by cosine squared is just 1 equal to, what's 1 over cosine? Look back at our notes. It's secant. So that's going to give me secant squared theta. This is also a little bit of foreshadowing. Sine and cosine like to hang out a lot. Cotangent and cosecant are really good friends, and tangent and cosecant also, no, sorry, tangent and secant are also pretty good friends. They have a lot of relationships to each other when we talk about derivatives in a few chapters. So one fun thing about all these trig functions is that they are periodic functions. What's a periodic function, Mackenzie? I'm about to tell you. So we can define it like so. So a function f of x, whoa, sloppy handwriting. F of x is periodic if there exists a p greater than 0 such that f of x plus p equals f of x for every x. That seems weird. I'll show you a picture in 1 second. So the smallest value of p is called the period. Alrighty? So let's draw sine. If I could find, what am I looking for? Blue. And we're going to draw sine for a while. Sine has actually, the whole number line is its domain, but its range is actually stuck right in between 1 and -1. So we start at 0 and we go, where do I want to make this? Yeah, let's make this pi and this one 2 pi, negative pi, 1, 2, 3, negative 2 pi. And I'm going to go up and down, then up again, and down again, and so on. So, even though at sine, we'll call this one sine of x. Sine of 0, sine of pi, and sine of 2 pi, those are all 0. So wouldn't the period of sine be pi? Not exactly. So if I draw a horizontal line, not a vertical line, at, let's say, its peaks, which are at 1. So peak starts with P, so does purple. So if I draw this little pretty line for when we're at 1, these values show up every 2 pi. So that makes sine's period 2 pi. It's actually fun because cosines is the same way. Ooh. So if tangent is sine divided by cosine, wouldn't it also have a period of 2? Not exactly. Tangent, remember we talked about in section 1.1 or even in section 1.2 about how a function cannot, if I'm dividing two functions, I need to exclude when I'm divided by 0 because that's a big no-no. So tangent is sine divided by cosine. So now when cosine is 0, tangent is not really gonna exist. So if I make these guys pi, which is when cosine is, hold on. Oh yeah, not pi, pi over 2. So negative pi over 2. That's when cosine is 0. So I'm gonna have these little, called asymptotes, giving tangent the property that is asymptotic. So tangent is gonna look like this on retweet over and over again. That actually makes its period pi. All right, so I lost my notes. This is really useful to use if I'm trying to calculate tangent of something I don't really know. I can break it down a few times and subtract a few number of pi's because I know tangent in between negative pi over 2 and pi over 2 is going to be the same at any iteration of pi over. All right? So before we move on to some addition formulas and half angle formulas, I want to teach you guys how to remember the unit circle. So we're going to call this a McTip. How to remember the unit circle. When I took calculus, or I think it was like math analysis or whatever like pre-calc was, I was just like given one, laminated, and told to put it in front of my binder and just memorize it. Just go off into the world and memorize it. I was like, whoa, okay. So if you look at your hand, I like to look at my left hand, it should kind of look like this. So if I could draw this right, hold on. Doo-doo-doo. So I'm going to draw my thumb and all my other fingers. Okay, please don't judge my drawing. So this is really important. So if you look at your hand, this is thumb. This is pinky. So on the unit circle, this coordinate is I'm out 1, I am up 0. In the unit circle, points go cosine theta, sine theta. And this one is 0, 1. So that means that this angle right here zero, let's do a little bigger. There you go. This right here is, whoa, zero degrees, right? So 0 degrees and also 0 radians. So theta equals 0. So that tells me that cosine theta of 1, oh, sorry, cosine theta when theta is 0, so cosine of 0 is 1, cosine and sine of 0 is 0. I also can count the number of fingers that are above my pinky. So technically I put my pinky down and I have 1, 2, 3, 4 things above. So cosine of 0, I'll have 4 fingers above, and sine of 0, I have 0 fingers below. So cosine's above, sine is below. I then take that number and I take the square root of it and I divide it by 2. So the square root of 4 is 2 divided by 2, that gives me 1. Square root of 0 is 0, 0 divided by 0 is 0. So this works for all pi over 6, pi over 4, and pi over 3, and pi over 2. So let's say I put my middle finger down, right? So now I'm at this angle right here. So I can do cosine of pi over 4. There are 1, 2 fingers above it, so that is square root of 2 divided by 2. And sine of pi over 4, I have 2 below it, so that's going to equal the square root of 2 over 2. So if you look at your hand, cosine of that angle is going to be square root of the number of fingers above divided by 2, and sine of theta equals the number of fingers below also divided by 2. This only works for these angles. These are the most important ones that you use: pi over 6, pi over 4, pi over 3, and pi over 2, because we already have these cute little fractions for them. This doesn't work for like 89 degrees. I don't know how to do that. I don't think you can do that with your hand. But you do have some helpful tools to find other functions that aren't on these 5 angles. This is also 2 pi. And the first one are called the addition formulas. So, addition. So the first one is cosine of A plus B. So if I wanted to find cosine pi over 4 plus pi over 2, I could add them right here and use this formula. And I'm not going to drive this for you guys, mostly because it's very complicated and I don't know it. So cosine of A plus B is going to be cosine of A times cosine of B minus sine of A, sine of B. Now, sine of A plus B is going to look similar, but not too similar. We're going to do sine of A, cosine of B, plus this time, cosine of A, sine of B. Well, these are addition ones. There has to be subtraction ones, right? We actually can derive the subtraction formulas. Formulas. No apostrophe. So if I do cosine of A minus B, I'm going to have cosine of A. I can think of this as cosine of A plus negative B. So cosine of A, cosine of negative B minus sine of A, sine, again, of negative B. Last section we talked about even and odd functions. So if we go up here and we look at sine, you can see that sine is symmetric over the origin. That means that sine is odd. So since sine of x is odd, hopefully you remember that means. It means sine of negative x equals negative sine of x. So that means that cosine of A minus B will equal cosine of A, cosine of negative B, we haven't touched that one yet, minus sine of A times negative sine of B. Well, a negative times a negative makes those both positive. What about cosine? I didn't actually show you guys the graph of cosine, but cosine is even. So since cosine of x is even, that means that cosine of negative x equals just cosine of x. So that cosine of A minus B is going to equal cosine of A, cosine of B, plus sine of A, sine of B. All right? So that's our next one, this guy right here. And we can do the same thing to get sine of A minus B equal to sine of A cosine of B minus now cosine of A sine of B. Right? Now, what if A and B in our addition formulas are the same? So I have cosine of A plus A. We called those double angle formulas. And if you plug A plus A into the cosine addition formula, we usually like to use theta now, so cosine of 2 theta, you'll be able to see that cosine squared of theta minus sine squared theta. Similar for sine, we'll have sine of 2 theta equal to 2 sine theta cosine of theta. There we go. Well, what if I don't want to double my angle? I actually want to take half of it. We have the half angle formulas. So if I have, they're usually written a little funky, so we're going to have cosine squared of theta divided by 2, half our angle. That's going to equal 1 plus cosine theta over 2, and sine squared theta divided by 2 will equal 1 minus cosine theta divided by 2. So you can take the square root of both sides, add a plus or minus in front of the square root, and get another formula as well. So there's also one more thing, and it's called the law of cosines. So if we have this fun little triangle, where A, B, and C are the sides, we're going to call this theta, this is C. And let's make this triangle actually not necessarily a right triangle. So if we have it more like, I like obtuse triangles. So this is theta, this is C, this is A, this is B. Since this isn't a right triangle, we can't use Pythagorean's theorem. We can use the law of cosines. So that says cosine squared equals A squared plus B squared minus 2AB cosine theta, that's where it gets the name law of cosines, because there's a cosine involved. Remember A, B, and C, that's the length of the sides. So you can use that as well. So let's do a few examples. So of how to use these equations. So this is in section 1.3, problem 43. And we're asked to evaluate sine 7 pi over 12. I don't know how to do that. Well, it gives us kind of a hint. So evaluate this sine 7 pi over there as sine of pi over 4 plus pi over 3. Alrighty. Well, let's call this one A. Let's call this one B. So remember that sine of A plus B equals sine of A cosine of B. I don't want to write it wrong. Plus cosine of A sine of B. All right, so A is pi over 4. So this is going to equal sine pi over 4 cosine pi over 3 plus cosine pi over 4 sine pi over 3. Beautiful. So sine pi over 4, if you use that little hand trick earlier, sine pi over 4, sine is the number of fingers below. I have 2, so that's going to be square root of 2 over 2. Times cosine of pi over 3 is going to be 1 divided by 2, 1/2. Plus cosine of pi over 4 is square root of 2 over 2 times sine of 1 of pi over 3 is square root of 3 divided by 2. When you multiply fractions, top times top, bottom times bottom. So 1 times square root of 2, that's just going to be square root of 2, divided by 2 times 2 is 4, plus square root of 2 times the square root of 3 over 4. I can combine those, and I can get square root of 2 plus square root of 2 times 3 over 4. Since these guys have the same power, I can combine them and make the power around both of them, which gives me square root of 2 plus square root of 6 divided by 4. And that's perfectly acceptable answer because it is the answer. So we can do a similar problem with 1.3.45. But now we're not given A and B, so clearly. So we're asked to evaluate cosine pi over 12. So let's talk about what A and B would be, and then I want you guys to work out this on your own, and I'll write you the answer and see if you get the final answer. So pi over 12. So well, let's see how they got the earlier problem. They got pi over 4 plus pi over 3. Well, pi over 4, I can rewrite that as 3 pi over 12. And pi over 3, I can write that as 4 pi over 12. Well, they added the two together, which is how they got 7 pi, 3 pi plus 4 pi. Well, what if I subtracted them? I would get 4 pi minus 3 pi. That would give me 1 pi. So if I write pi divided by 3 minus pi divided by 4, I get 4 pi divided by 12 minus 3 pi divided by 12, which gives me a lone pi over 12. And then I can plug it into my subtraction, and I would get what? I would plug it into cosine of A minus B dot dot dot, and I hopefully will get back out what? I think I should get square root of 6 plus the square root of 2 over 4. Let me know what you guys get. So, what other problems can we think about? Well, what if I ask you to solve just kind of an arbitrary function? So let's do, this one's kind of my favorite. It's problem 53, so 1.353. Let me underline these. There we go. So that one asks us to find all thetas such that 0 less than or equal to theta less than or equal to 2 pi. So theta is just kind of in one unit circle, right? Because we can keep going around and around forever. So we're just going to keep it down to one rotation. So we're given sine of 2 theta minus cosine of theta equals 0. All right, well, I know sine of 2 theta is what? It's going to be 2 sine theta cosine theta minus cosine theta. Well, awesome. Each term now has a cosine in it, and I can pull it out. So I'm going to have cosine theta times 2 sine theta minus 1 equals 0. What we know from when we did a lot of stuff with polynomials in algebra is that for these two things multiplied by each other to equal 0, at least one of them has to equal 0. So either cosine theta equals 0 or 2 sine of theta minus 1 also equals 0. When does cosine of theta equal 0? At between 0 and pi over 2. It's going to be at pi over 2 and 3 pi over 2. So then we have 2 sine theta minus 1 or 2 sine of theta equal to 1. So sine theta equal to 1/2. When does sine theta equal 1/2? Let's go look at our hand. It's at every pi over 6. And it's positive 1/2. Remember that we're only going to be positive in the first quadrant and the second quadrant. So, where were we? There we are. So we're going to have it at pi over 6 and 5 pi over 6. If I went beyond and chose 7 pi over 6, that would actually give me a sign of negative 1/2. So that's why it's good to know that quadrant trick of all students take calculus. All right, so I think that's where we're going to end it today. Let me know if you guys have any questions, any comments